Good morning, boys. Today we are going to start elementary row transformation on a matrix. There are three different operations on matrix, three on row and three on column. So total 6 operations are there on a matrix, and we are going to look one by one. The first operation is like this. The interchange of any two rows or two columns. The interchange of any two rows or column. That means I can interchange Ri with Rj or Ci with Cj. Now second operation on matrix goes like this. The multiplication of the elements of any row or a column by a non-zero number. The multiplication of the elements of any row or column by a non-zero number. That means what? It's very simple, that Ri tends to k times of Ri, or Ci tends to k times of Ci. So guys, here the two, till I explained you two elementary operations or matrices, either on row or column, simultaneously we can go, there is no problem. So first is the interchange of any two rows or a column of a matrix. That is Ri, that means we can say R1 to R2 or R2 to R1. Similarly C1 to C2 or C2 to C1. And the second operation is the multiplication of the elements of any row or a column by a non-zero number. That means we can multiply all elements of any row or a column of a matrix, and that can go like this way. Ri tends to k times of Ri, and Ci tends to k times of Ci. Now we'll move on to third operation. The third operation goes like this. The addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. What does it mean? It means Ri tends to Ri plus minus k times of Rj. Now, it is very important to understand this third operation. That is very important. See how to understand? Look at it. The addition to the elements of any row or a column to the corresponding elements of any other row or column multiplied by any non-zero number. That means if R1 tends to R1 plus minus multiplied by some non-zero number to the R2. That means R1 tends to R1 plus minus some number multiplied by the R2. That means we are changing whom? Row 1. Now we'll look into further. Guys, these are the three basic transformation operations, elementary operations, which are going to be used to find out the inverse of a matrix. That is why we called it to find the inverse of a matrix by using the elementary row transformation or the column transformation respectively, either by row operations or by column operations. So basically we are using these three operations and we'll try to find out the inverse of a matrix. The question arises, what is inverse of a matrix? Invertible matrix. Invertible matrix. It is always try to understand that inverse of a matrix is only possible for a square matrix. Only and only for a square matrix. If you wish to find out the inverse of a matrix, we'll look into always a square matrix and have a inverse. Otherwise, if you talk about a rectangular matrix, sorry, there is no inverse for a rectangular matrix. Inverse of a matrix is only possible for the square matrix. We will always keep in mind this. So now we look at a definition for the invertible matrix. What is it? If A is a square matrix, if A is a square matrix, if A is a square matrix of order M, fine. If there exist another square matrix B of order M such that AB is equal to BA is equal to identity matrix. A into B is equal to B into A is equal to identity matrix. That means B is the inverse of a matrix A. That means implies that B is inverse of matrix A. Matrix A and vice versa. What do you understand? Inverse of a matrix is only possible for a square matrix. That's the first thing we need to understand, right? Then what is the definition of the invertible matrix or the inverse matrix? Is if A is a square matrix of order M, it can be of order 2, it can be order 3, it can be order 4, but we are precisely focused into the standard only of the order 2 and order 3, not more than that, and not less than 2. Because less than 2 is only one element. It's very simple, you understand, you know better. So if A is a square matrix of order M, and if there exists another square matrix B of same order, that is order M, such that A into B is equal to B into A is equal to identity matrix. Hence, B is the inverse of matrix A. And vice versa. Of course, then A is the inverse of the matrix B. Very simple. So, okay, this is the definition of inverse matrix.